Hello Ben, good morning.
Good morning.
Nice to meet you here in El Escorial, in this beautiful place, attending the summer courses.
It's absolutely a delight to be here. It's wonderful. Great.
It's a privilege for us. It's an honor to have you here. So thank you very much indeed.
It's also an honor for me to be here.
Students are enjoying with you very much.
Okay.
You are encouraging them also for promoting science and so.
Yeah,
so I would like to know, and many people would be interested in knowing about some aspects in general science,
Sure.
in particular some aspects related with nanoscience as well, and also some singularities about your more personal details. Okay? So I have here some, let me first of all to introduce to the people that you are a great scientist, and as a consequence of your science you developed for many years, in 2016 you got the Nobel Prize together with two friends and colleagues of you in chemistry for the design and synthesis of molecular machines. Just tell us, just for starting, this was not in my questions, but how was that day when both three guys received such a distinction? How was the day? What do you remember of that?
The most important was, of course, the 5th of October, when the announcement was made. I was with my students, you know, in my room discussing some tough chemical problem, and then the telephone rang, and my first thought was, who is going to disturb us? Because we were in a discussion, you know, a scientific discussion. But then I took up the phone, secretary of the Nobel Committee, and so I sent the students out, and I listened, and then after 4 minutes or so, he said, Dr. Feringa, are you still there? It's so quiet. And I said, yes, I'm in a shock, because it comes so unexpected and it's so special. And then in December, the 10th of December, you know, we have this ceremony in Stockholm, of course, where they celebrate, you know, you get your gold medal from Her Majesty the King, and it is absolutely fantastic. It's a dream, you know.
Unforgettable.
It's unforgettable, yes, absolutely, marvelous.
Yeah, right. Yeah, just let me tell you that you said October 5th, and there are many people, I am included in this group, that I open my mobile phone just in case. But unfortunately it never happened.
I didn't open my mobile phone. I was discussing with my students, you know.
Okay.
Yes.
Okay, anyway. So let's go. People would like to know about you, but my feeling is to go from the general aspect to the most particular one. So my first question is science the solution to the many important societal problems we have related with our planet, with our lives? I mean energy, I mean water, I mean the environmental issues. Is science the solution, or is not enough?
Now, science is certainly a major part of the solution, but you need also to encourage the people, you know, to change attitudes, maybe, you know, the way we are doing things in society, how we deal with each other, you know, and how we behave. For instance, our consumption of goods, all these things, you know, how we deal with transport, for instance, travel, energy consumption. But science, of course, we should not forget that we have a modern society is to a large extent due to science, that we have modern drugs, that we have a smartphone, that we can build electric cars, yes?
Yeah.
That we have all these products, you know, that we use every day, that we have sufficient food. So the insights and the knowledge that we developed over the past 150 years, say in science, is crucial for our modern society. And of course it will be crucial for the next steps to build a more sustainable society of the future. Yeah?
But citizens, I think in general in all countries, particularly in the developed countries, and in Europe and in America, they are demanding that to the authorities, to the governments, to be more energetic in this regard. And what can we do? Because at the end, it depends of the solution, the potential solution, and economy is in the base of all these matters.
Yeah, but of course, if you think about energy carriers nowadays, you know, making energy, you know, from solar, or from hydrogen, all these things are wind, windmills. is becoming very, very, very important. All these solar panels on the roofs, etc. So this is already an important contribution to the energy problem. But to store energy is a different thing, you know, to make good batteries, you know, energy storage, etc. So we need scientists, chemists, physics, material scientists, engineers, theoreticians, everybody to help to develop energy storage systems. This is just one example. And so there are many examples where we need this input from scientists to make it possible that we get solutions for these kind of pressing problems. Yes, and the same holds of course for societal issues. How are people communicating with each other? How are we dealing with people from different cultural backgrounds, you know? How are we educating our young people for the next, because they will be the innovators for the next generation. They will lead our society. So we have to confront them with new insights, new developments, and so science and education is the basis. It's crucial in my aspect.
Thank you for your comments, because well, I fully agree, and we are in the process in the meantime. Okay, so let's go one step down. This classification. What's that? Nanoscience. Let me ask you, is different to conventional science? Is a different kind of science?
I'm happy that you asked this question. Let's first put it in perspective. Everybody knows about microtechnology, microscience, When you have a camera, when you have a smartphone, microchips are everywhere. This is microtechnology. But now we went smaller and smaller, and nanotechnology, nanoscience, is 1,000 times smaller. So we are at the level of molecules, like in your body, you know, the molecules, the DNA, the proteins, etc., the whole machinery in your body. And so this development has gone on now for the last decades to move towards smaller systems, materials that are organized, structured, have functions at the nanoscale, not the micro scale. Just another comparison. Your body is full of nano machines. The fact that I can talk to you, that I can lift my arm, that I can wave my hand to you. All these things are powered by nano machines in your body. Tiny machines made of proteins and so that make it possible that I can speak, I can see you, etc. But in general, we are not so good in making machines at the nano scale. Everybody that has a car has a nice motor in there. This is macro, An airplane, a train, the machines in our factories, you know, the robots. But this is all macro. Now going to the nano scale, nano means 1 billion of a meter, 1,000 times smaller, than micro. Okay, and to back at that scale, we have to learn, to look at Mother Nature, for instance. How does Mother Nature deals with this nanoscience, with this nanotechnology, in making all these machineries in your body and so. And this gave us the inspiration. And this is what will set the stage for new technology for the future.
So can we say as a conclusion that size matters?
Size matters a lot.
And that there is different rules or different properties with the size of the matter?
If you are at these small scales, there are different properties, you know. You cannot easily compare a nano machine with a machine in your car or in your airplane or in your factory. So indeed, there is a different world, First of all, it's the world of soft materials, but of course you can also make hard materials at that scale. But the interaction between these small parts, how they cooperate, how they work together, all these things are different from what you experience at the macro scale.
Great.
For instance, gravity, just give you an example. We all know how heavy a car is. I never lifted a car, but apparently some people do. You know how heavy a motor is, This is all based on gravity, the weight of something. But at the nanoscale, 1 billion of a meter in size, gravity, weight does not play a role. It's the interaction between the small components, how they communicate with each other, how they interact. That's the dominating factor.
Great. So we are in the front of a new scenario.
We are in the front of a new era, a new scenarios, how to develop technologies, you know, where we can control everything at the nanoscale.
Perfect. So one step further, you have been talking about machines at the molecular size. Why then we have to to go to these machines. Do we have to prepare now molecular machines, and why?
Yeah, we got our inspiration from Mother Nature. Yeah, you know that in your body, as I mentioned before, it's full of nano machines. Yes, that I can talk, that you can breathe, that you can move, that things are transported in your body. Yeah, that you can see each other, communicate. So these are all these tiny motors and machines in your body that make that possible. These are motors and machines at the nano scale, 1 billion of a meter in size. But if you look around you, most of the things here don't move. We make all kinds of things, but they don't move. We are very good in making plastic, but plastic does not move.
Yeah.
Now we made a nano machine, put it in a piece of plastic, and the plastic starts to move.
That's great.
Yeah, and then you can say, okay, why is it good for? But you can dream then about making small robots in the future of responsive materials, things that change properties. Yeah, maybe materials that can heal themselves, repair themselves.
Okay, as a human body.
Like in the human body.
For instance.
Yes, and that is due to all this nice nanotechnology.
That's great. And you mentioned robots.
Yes.
And that is my next question is related with artificial intelligence.
Yeah. Oh yeah.
Let me, first of all, just let me A or B. I'm going to say A or B, and you say A or B, and then you can explain me what you think.
Yeah.
Is a very useful tool, or is a revolution?
I think it's a very useful tool, A. Yeah?
A. And why?
Why? Because you have to realize you can use artificial intelligence, that you feed a computer program with data, they come up then with original solutions, and it will give you new ways of thinking, new ways of doing things, but most important, that it takes a large collection of data, and finds something in these data that is useful for your next steps, for instance in making materials or in your fabrication or whatever. Is it a revolution? I don't know, because I think creativity is also really important for revolutions, very original ideas. And of course artificial intelligence will help to create original solutions. But if it will be more creative than human beings, I doubt that, So I see it more as a tool, like we use computers, we have now so many data, so much information. How to handle that is difficult for a human being. But if you use computer programs to do that and to get something out of that you have not thought about, it will help you. So I see it as a major step, towards using complex data sets and systems to come up with new solutions, new opportunities. But human creativity and intelligence will also be very important.
Well, human has been almost 1 million years on Earth, but artificial intelligence and robots only 100 years.
So there will be fantastic opportunities, and we will see these robots that are intelligent and that can do all kinds of things, but I don't think they will replace humans at all. They will help us, they will make things easier, like we have robots in our factory. If you have ever been in a car manufacturing plant, I'm impressed always, because I see these robots and they assemble a complete car. Almost no human interference. It's fantastic.
Yeah, but now you put together molecular machines or nano machines, you put together artificial intelligence, and do we have a problem for future or not?
No, I think, you have to of course also build in some safety issues, because if you make these nano robots and you build these artificial intelligence programs, etc., you feed them with a lot of data, they might go crazy and do all kinds of things that you don't want. But you know that if you instruct it properly and you build in some safety measures and say, look, okay, this is as far as you can go, as a robot, I think we should do that. You cannot leave it unlimited, but that does not mean that there is not a danger that some will go awkward. This happens with new technologies. Some things might go wrong.
Drexler was in the 80s. He wrote the Engines of Creation, a book that was, it has a lot of impact on society in the sense that he said nano machines can ensemble all together to form more complex systems. And at the end, it could be a danger for the human being in future. It looks like at the beginning you smile a little bit saying, but today with artificial intelligence, it was, the other day I was watching TV in the news, and there was a robot, and there was an interviewer, a human making the interview to the robot. And one of the questions was, do you think that you are better prepared than a human being, for instance, to become the president of the government? And the robot said, honestly, I think so. So, and well, it's, in some cases it's not difficult, the robot, but in other cases, yes, I would say yes. But anyway, the robot said, and another question was, would you expect in future, if the situation with a human being is not right, would you take the command, or would you take and the robot said again, human beings are very, the behavior of human being is very nice with us, and so there is no reason for that. But it's a little bit,
I don't know. You know, that is with all kinds of new technology developments. Artificial intelligence, people are a bit scared of it because they think, that robots can take over. And I also read these books, and these stories, etc. I'm less afraid because, but we have to make this kind of ethical discussions. How far do we want to go? What do we want to have under control, yes or no? And the same holds when you develop new medicines and whatever. The most scaring robots now, the most scaring are viruses.
Yeah.
We have seen that during the COVID crisis. These are natural robots, You can consider them almost robots.
Yeah. Viruses.
And bacteria and so. To me, that looks maybe more dangerous, than these artificial robots. Having said that, if the developments go on and you build in these programs and they become autonomous and they do all these creative things, they can go do very, very strange things, But that means also that we have to think about how far do we want to go, Do we want to control them at a certain stage? Yes, etc. But I'm an optimist, I think we are able to develop technologies, and I don't think robots will take over human beings. What will happen though is that we will get hybrid forms. That is to say, we will get more and more electronics components integrated in your body. You see there's now already with sensors, with pacemaker or an artificial knee. But in the future, we will have we have artificial skin. You see already beautiful examples, with electronics in there. And in the future, maybe we get a chip in our brain. And then they can control maybe remote parts of your brain function. To me, that is more scaring,
Absolutely, absolutely, that's the point. Actually, science fiction has been shown to society in films, books, and so on, in a premonitory manner. And in this regard, there are many films that in our memory. But for instance, Terminator are machines coming back from the future, and
it's not impossible.
So it's a little bit.
So in my opinion, you cannot prevent these developments. Artificial intelligence will come. It's already there.
I would say robotics. Even more. I would say it's impossible to prevent it.
But we can think about potential dangers. What do we want? What do we not want? And so to make control measurements, to make rules for this, etc., and to build in safety and security. But of course, you can never prevent that something goes awkward.
It's impossible to
control
close
everything.
The experience says that it's impossible. Let's go to more personal details. People want to know about you. Did a Nobel Prize, to get a Nobel Prize, change a life?
Yes, it changed dramatically in my life.
Dramatically?
That is to say, not in the sense how I teach or do research or so, or personally, but of course, you realize this is the highest scientific honor you can get. And people recognize that and look at you, and of course you get a kind of a celebrity status. So people think, okay, you are a kind of celebrity, a hero in science, and among the best of the world. So that means that people recognize you in the street. People are very proud. You know, I'm also very proud, you know, what we accomplished, and of course on this you should. But also people look at you and say, hey, you are how do you call it? A well-known public figure. I saw you on television. I forgot your name, but I will come to it in a moment. And they congratulate you and say, look, we are so proud of you, and you are the hero, and whatever. And it's rather amazing, you know, how many reactions you get, and people want to have pictures with you and want to have signatures, and this is rather amazing. I had to get accustomed to this status. I know now what it means that people are working in Hollywood and become a movie star, you know, or they are a pop star, you know, because you have to put signatures and pictures, how it goes, photographs all the time, and people talk to you, and people. It is like a fairy tale.
Yeah, I can confirm it. And, actually, I'm very proud to have you as a friend. And in addition, during these days in Escorial, I don't know, hundreds of pictures with colleagues and students and the people and so on. So
but it also brings responsibility, because you realize that people look at you as also, they expect you to be also an advocate for science and education. So this is what I did after at the Nobel Prize. The journalist asked me, what are you going to do? Because this is the highest you can get. Do you stop now? Yeah? I said, look, I'm like an artist, you know, I'm not, an artist does not stop making music. I'm not stopping doing discoveries and sufficient. And I like teaching, so I will continue. But also, I promised myself to do something more on outreach, to make clear to the public, to the politicians, to general,
that is important.
How important is science and education. Education for the next generations, you know, the basis for our future. And I built a foundation. And with this, what we do is we go with students, from our university, from our institute. We go to schools, elementary schools, high schools. We give kind of discussions with the students. We do experiments with them, just to encourage their creativity and stimulate them. And we wrote a popular book during the COVID crisis about chemistry, so to make people more aware how important science is, because you cannot expect that everybody understands what fundamental science means and why it is the basis for our next generation smartphones or for the new medicine of the future. So this is what I do. Yeah?
Okay, I hope you can send me one of those copies of the book.
I will do so.
It's a deal.
Yeah.
Okay.
Yeah. It's in Dutch, you have to learn Dutch.
Dutch? Oh, come on. Okay.
We try now to translate in English.
Okay, I'll do my best, but it's not my strong.
No.
Okay, anyway. From this viewpoint, I think you are doing as much as possible to contact with responsible people, the responsible persons, to decide about the investment in science and technology and so on. And do you agree that some years ago scientists approached to the responsible people to say we need money for research? But today the approach is completely different. I approach to you to say if you consider science, the solution of science to many of the problems, and when you take a decision, probably you will do it much better. Yeah. Do you agree with this statement? Science should be supporting political decisions in many cases.
I think we have an important duty, not only to advance knowledge, to educate our younger generations to do discoveries, go beyond the frontier of current knowledge, science and discoveries, but we have also a very important duty to do outreach, to make clear why science is so important, and in particularly to our politicians, you know, and the government and the people that are in charge of funding and all these things, to make clear why they should invest in a good science basis. Because a science basis that provides the insights, the knowledge and the data, the techniques, the data, to make it possible that we can do discoveries, we can have new solutions. If you want to have a new to fight the the COVID virus, yeah, we need pharmaceuticals. We
Absolutely.
need drugs, yeah, and they developed it very quickly because they had a knowledge basis of 40 years of new ways to do things, you know, like the microRNA technique, etc. That made it possible that in 1 year we could develop these vaccines. The same holds for a lot of other new developments. If you want to have better batteries, you know, yeah, or if we want to recycle plastics, yeah, or our materials in general, we have to convince the policymakers you need the insights and the data, because otherwise it will not be there. We have to do science to come up with all the data, insights, etc., so that our industry can build on that and make it possible for us. Yeah?
Fantastic.
That's what is needed.
Thank you for your comments. Let me finish with a question that young people, I've been talking with many of the students from my students, but also all the students attending the summer school devoted to nanoscience. So, and you encourage them very strongly. And from this viewpoint, I feel that most of them, their hopes are just to become an important scientist like you, if possible. And what advice would you give to people which is engaged with science, but at the earlier stages? So what is important for them? I guess that now in Spain, we have had, and in other countries I know as well, some ethic problems related with the number of publications on many other aspects, how funding projects and so on. So assuming that ethics in science is important, what advice and in this particular aspect of ethics?
Talking about ethics, I think we educate at our universities, the young talents, the students, which will be the leaders, you know, in industry and society in the future. I think besides educating and training them, in their disciplines, it's also crucial that we discuss ethical aspects. That's integral to a university education, in my opinion. We should do that, you know, about what are the standards, you know, that we want in learning, in teaching, in discovery, in making things, in industry, whatever. There are all kinds of ethical things, you know, that you have to think about. And I think in universities we should have these discussions with the students. Yes, it's an important part of the training. Ethics, is an important part of the training. It's a very important part. And regarding, you know, what you can publish, you know, you should base it on facts and data and insights. And also that it is not just dreaming of something, but you have to do, you have to develop it in something that is solid and that you can stand behind it, you know. You cannot just fantasize. But I think on the other hand, it is extremely important that we encourage our students that they should be confident, so to learn, to discover, to be eager to learn and discover. I think it's really important, because there is so much that we don't know and that we can do discoveries, etc. And young people, you know, of course, they always look at big discoveries, you know, people that get a Nobel Prize or made a big invention. But we all started as a student and doing very small, maybe insights and discoveries. And with these small steps, you build your career. And it's extremely important to be proud on the small steps you take.
That's fine. That's very important. But don't you think that we are perhaps putting too much pressure on very young students in getting papers in top journals, and this pressure could deviate a little bit
this whole pressure, you know, is going over the top. This whole pressure of publishing, etc. Of course, you want to have some results and publish it in nice papers, etc. But there is this tendency of pressure on publications, you know, impact and so. And I don't think it's so important. It's important more that you have, for instance, one publication which can make some difference, give some new insight. And it doesn't mean that immediately it should be useful or applied, but it gives you the satisfaction that you added something to this beautiful house which is called the House of Science and Knowledge. Yeah, and I think this is really important, and you should be proud of every small thing, the step you make. And I think for young people, I said that yesterday also, and I will mention it today, follow your dreams, you know. Dream also a little bit. When you are young, you should not only focus, oh, I need a paper or I need to do an exam. Also find time to dream and to be creative, and that's also very important, you know.
Wonderful advice, wonderful advice. So I think we are at the end of this wonderful and unforgettable interview to you, my friend, and I hope we can repeat in future, because you are a friend of the Spanish science, not after the Nobel Prize. Many years before getting the Nobel Prize, you was a friend of the Spanish science. So it's a pleasure to have you here, and this Complutense University is always open to you at any moment. So
it's fantastic, you know, as a scientist, that you are a member of the academic community around the world. We have friends everywhere, and it's a real joy. Knowledge, learning, and discovery.
That is the title of your lecture, just in a few minutes. It's a great pleasure.
Great pleasure. Thank you so much.
Thank you, Ben.